right? Here, a halogenation of alcohols. So here, halogenation of alcohols, alcohol OH is been substituted by a halogen group, and it is an example for a substitution reaction, right? It is an example for substitution reaction. In substitution reaction, you will discuss very extensively about this thing, right? So SN1 and SN2, you will discuss about this type of reaction. Okay, how halogens are going to substituted here, right? Right here, the halogen sources are like this: hydrogen halides or HCl, HF, HBr, HI, hydrogen iodide like this, or sulfuryl halide. Okay, SOCl2, SOBr2, right? Next, phosphorus tribromide or phosphorus trihalide or phosphorus pentahalide in presence of zinc chloride catalyst and heat. So you are going here, you are going to get halogen substituting this alcohol group, right? Right. Till the last slide, we have come across the preparation methods of halogen compounds, right? Right. So how halogens are prepared, we come across all these things. So from alkenes, and from alkynes, and from aromatic sources, and from alcohols. Okay. So here till here, you can see we prepared many methods to to prepare alkyl halogens or aryl halogens or halogen compounds. And here, this is up to here, this is a preparation part of halide compounds. And from next slide, we are going to see the chemical properties or reaction modes of halogen compounds, how they react in a chemical reaction, right? So as we already discussed, this carbon halogen linked bond is highly polarized. This bond is highly polarized. Polarized means that will become weak, right? So it has already become weak, and so when you react it with in the presence of a nucleophile source, a nucleophilic source, so this nucleophile will substitute this halogen group, right? This nucleophile will substitute this halogen group, right? So how this nucleophile approach this halogen compound is very, very important. So depending upon the way or the mode how this nucleophile is approaching this halogen compounds, so we categorize this substitution reaction into SN1 mode, SN2 mode, and SNI mode. So unimolecular substitution reaction, bimolecular substitution reaction, and nuclear substitution via intermediate, like this. Okay, so we will categorize this substitution reaction, how this nucleophile is approaching this alkyl halide in the nucleophilic substitution reaction. So here many number of nucleophilic sources or nucleophiles are mentioned. There are neutral nucleophile sources, right? So OH is having an non-bonding electron pair OR and OCOR, right? And amine group. Okay, so this is a secondary amine group, and this is mercaptalar thiol, thiol group, right? So alkyl substituted thiol, cyanide, next any other halide. Next, this is a very important case, and this is carbanion. Okay, alkyl carbanion, right? So these are all nucleophiles. Nucleophile means they are the source of electron pair. Okay, they can donate electron pair or electron rich centers, right? So we will discuss. So first we will see how the reaction will occur. Here the nucleophile will attack on this alkyl halide, right? So here, so upon attacking of the nucleophile, here see in the case of this bromine or alkyl bromide, right? This dilute KOH, it is having a nucleophile source that is OH, right? Like this, right? This OH will attack on this compound. You are going to get a alcohol, right? And here NaCN, it is having a nucleophile source as cyanide. So cyanide will substitute this chloro, right? You are going to get cyano substitution compound. And here phenoxide PHO minus. So phenoxide will substitute this chloro. And here alkyl carbanion. Okay. And here sodium iodide Na plus and iodine minus. So iodine will is more nucleophile than bromide, right? So iodine will substitute this bromide, right? So and these are the other type of elimination. The second type of reactions are elimination reaction. Here in the case one, okay, so they can participate in nucleophilic substitution reaction because this bond is very weak. This nucleophile get substituted by this nucleophile. So a weak nucleophile is been substituted by a strong nucleophile. Here weak nucleophile is halogen and strong nucleophile will be these compounds mentioned beneath here, right? Right. So here, depending upon how nucleophile is attacking this alkyl halide, okay. So it depends upon so the structure of nucleophile and the crowding at alkyl halide, and it depends upon the condition, reaction conditions. Okay, what type of reagent you are using, what type of catalyst, what type of solvent you are using. So that also decide what type of reaction this alkyl halide or nucleophile will undergo. Okay, so it may be through SN1 or it may be via SN2 or it may be via intermediate, right? So you can see SN1, SN2 and SNI in this nucleophilic substitution reaction depending upon the crowding or the structure of the alkyl halide, depending upon the nucleophile and depending upon the solvent you are using. Okay, solvent and reaction conditions you are enforcing, right? So these reaction conditions and the structure of alkyl halide will decide whether this reaction is completed through SN1 mode or SN2 mode or SNI mode. Okay, so we will discuss deeply about SN1 and SN2 and SNI in the next classes, right? So, and another type of reactions possible in alkyl halides is, okay, so here after substitution, So there is a possibility of elimination, right? So there is a possibility of elimination, alpha beta elimination. Here a halogen substituent, and here in the alpha position you may have hydrogen. So right, in the case of substitution you are using dilute alcohol, right, and dilute